we're going to do is we are going to actually figure out what is the size of a tree and the height of the tree, and let's say what is the minimum height of a tree, right? So in this example, like pretty simple, it's just a recursive calls in the binary tree. So size, what we'll do is we'll probably go pre-order, in order, or post-order, any order that we want, and like we'll figure out if the node is actually not equal to null, then the size is actually equal to 1 plus the size of my left side plus the size of my right side, right? So that'll basically give the size. So if I reach a node and that node is not null, if it is null, then we actually will return 0. If it is not null, then we will add 1, and then we'll call recursively find the size of the left side and recursively find the size on the right side. That is basically what the code is. The height and the minimum height is also similar code. These are pretty simple 3 or 4 lines of code. So let's actually write the code for that. I already have written the code for the node. So the node is basically a left and right and t data, and whatever data we pass over here, that comes over here. Binary tree is just a binary tree which has a root, and in the main, what we do is we actually have a create tree function which actually creates this tree. So we initialize a tree, and then we say tree.root is the create tree. Okay, so let's actually write the code for public integer size. So that'll actually return the size of this. This is a wrapper function. We will say return size, and we will actually pass root over here. Now we need to write the function for the root. So we'll say private integer size, which will actually take root node. Okay, so we have the node over here. Then what we'll do is we'll first check if node is equal to null. If node is equal to null, so in that case, we just return 0. Right? If the node is null, we return 0. If not, what we'll do is we'll return 1. 1 is basically us. The size is actually 1 plus we actually figure out what is the size of my left side and what is the size of my right side. That basically just few lines of code that should basically give us the size of the tree. So in this case, there is like 11 nodes, so we should actually get the size as 11. So we'll say SOUT, and we'll say tree dot size. Let's just run this, and this should give us 11. Hopefully 11. Okay, so that works. Similar to this, we actually have the height of the tree, right? So for figuring out the height of the tree, what we'll do is we'll say that, let's say we reach 1. We reach 1, then that means that there's at least the height is actually 1. Then we'll figure out which side height is actually bigger. Either the left height is bigger or the right height is bigger. Based on both of them, whichever one is bigger, we will say height is equal to 1 plus height of my left side, or math.max of height of my left side or the right side, right? So that's basically what the code is. This code is also pretty much same. So we'll say public integer height. We can probably save the height in a particular variable and stuff like that, like we do in AVL trees. We'll actually do that, but this will work also. So we'll just say return height, and we'll pass root over here. Private integer height, which will take node. We'll check if node is equal to null. If node is equal to null, that means that the node doesn't exist. We just return 0. The height of that one would be 0. Otherwise, what we'll do is we'll say integer left height is equal to height of my node.left, and we'll calculate the right height. Okay, so these are recursive functions. We'll basically go over there and try to figure out. Let's assume that this one gives us left height, this one gives us right height. Then what we'll say is, we'll say return 1 plus 1 is our level plus math.max of left height comma right height. Okay, I think that should basically just do it for us. So if we want to figure out the height of this tree, so height of this tree is 1, 2, 3, and 4. So this should actually return us 4. So we'll come over here and we'll say tree dot height that'll return us 4. Okay, let's say we want to find out the minimum height, right? So minimum height is basically just the same as the height, except we'll just copy this. Okay, so instead of this, it'll be minimum of left as well as right. So let's say, for example, this 9 did not exist. So if this 9 did not exist, then the minimum height would be 1, 2, and 3. 3 levels, because that is level 3. So we'll actually try that out. So we'll go to our main. Let's actually remove 9. So we actually don't have 9. So in this case, our minimum height should remain the same, but the minimum height should be 3. Okay, that is good. Let's see you guys in next video.